Hello friends, I am Dr. Lokesh Desai, and in the previous videos we have discussed model explanatory power by examining R square, adjusted R square and F square. Now in this video we are going to discuss the predictive power of SEM model. In the explanatory power, developed model estimate based on observed sample and it is based on training data. Whereas in the predictive power, it indicates how much your model is accurate for the outside sample observations and it is based on testing data. Before executing predictive power of SAM model, you must complete PLS algorithm and bootstrapping. Now, the PLS predict algorithm is used for this analysis and it has been developed by Shumeli et al. 2016. The method uses training and holdout sample to generate and evaluate predictions from PLS path model estimations. In this algorithm, softwares divide data into two parts. The first one is training data and second one is testing data. The training data is related to the data or sample that is used to estimate the model, whereas testing data it is related to the data or sample that is not used to estimate the model. The training data provides model estimates such like beta, R square and F square, whereas testing data provides predictions and has no influence on estimation or estimate the model. Now, PLS predict algorithm implementation in the smart PLS software allows researcher to obtain k-fold cross-validated prediction errors, and prediction error summarizes statistics such as RMSE, root mean square error, and MAE, mean absolute error, to assess the predictive performance of their PLS path model for the manifest variable, it means MV or indicator, and the latent variable that is LV or constant. It means the predictive relevance power of model can be studied at two categories. The first one is manifest variable at an indicators level and second one is LV, it means construct level. If the Q square predict value is positive, the prediction error of the PLS-SEM results is smaller than the predictive prediction error of simply using the mean values. In this case, the PLS-SEM models offers best or better predictive performance. Now, there are two main activities involved in this software, the number of folds and number of repetition. Default value is 10 and in k-fold cross-validation, the algorithm splits the full data set into k equally sized subset of data. The algorithm then predicts each fold with the remaining k minus 1 subsets which in combination become the training sample. For example, when k equals 10 or 10 folds, a data set of 200 observations will be split into 10 subsets with 20 observations per subset. The algorithm then predicts 10 times each fold with the 9 remaining subsets. And the number of repetition default value is 10. The number of repetition indicates how often PLS predict algorithm runs the k-fold cross validation on a random split of the full dataset into k-fold. Traditionally, cross-validation only uses one random split into k-fold. However, a single random split can make the prediction strongly dependent on this random assignment of data into the k-folds. Due to the random partition of data, executions of the algorithm at different points of the time may vary in their predictive performance results. You can find the same literature on the source Ringel et al. 2024. Now, the software executes two types of prediction. The one is based on PLS-SEM model, and second one it is based on the linear model that is also called the reference model. And the rule of thumb is if the prediction Q square of PLS-SEM is less than the linear model, then your model is considered as a good fit. If the prediction of PLS-SEM greater than linear, then your model is not good fit. Now, how we can execute with this software? So I open the software now. This is our ongoing model in which social support, financial well-being and work-life balance, all together these three influence happiness and happiness leads to life satisfaction. So we have done the two process, we have completed PLS algorithm and bootstrapping, and now we go to calculate and click on PLS predict or CVA PAT. So click on PLS predict. So by default, number of folds and number of repetition by defaults, these are 10. Start calculation. And now you have to check left hand side, and we have to find the PLS MV summary and PLS predict LV summary. So we click on PLS predict MV summary. It means manifest variable overview, and we can find this type of table. So how to analyze this one? In this table, certain columns are there. First represents Q square predict values. Second, PLS-SEM RMSE, PLS-SEM MEE. So these two columns, they represents the estimate model, our PLS-SEM model, and next two column LM RMSE and LM MEE, they represents LM benchmark reference model, and then IA RMSE and IA MEE. These are the two last columns. So rule of thumb for PLS predict table is as follows. The Q square predict should be greater than 0, then the model has a predictive relevance. Second is PLS-SEM error. If less than the LM error, then it indicates high predictive power. PLS-SEM error slightly greater than LM error, then it indicates the moderate predictive power. The PLS-SEM error, if it is greater than LM error, for most indicators, it indicates the low predictive error, low predictive power. And if the PLS-SEM error is less than IA error, it means indicator average error. Model predicts better than the indicator average. So in this way, compare RMSE or MEE values. If these lower values are there, then that indicates a better prediction. So PLS predict MV summary, manifest variable summary or indicator level predictive errors, RMSE or MEE, and comparison with the LM benchmark. It means linear model benchmark. So you have to compare these two values with this LM RMSE or LMMEE. If your estimate model PLSM values or errors are less than the LM benchmark, then your predictive relevance power of PLSM model is good. Now, this is a path. Compare RMSE from the PLSM analysis with the LM values for each indicator of the key target constructs. RMSE are all PLSM values less than LM values. If it is yes, then the model has a high predictive power. If it is no, then again you have to find out RMSE are most values, PLSM values. If it is less than the LM values, then the model has a medium predictive power. If it is no, then RMSE are all PLSM values greater than LM values. If yes, then the model lacks predictive power or low predictive power. And if it is no, then the model has a very low predictive power. So in this way, you can make your decision for a predictive relevance power of SEM model. Now, the next step is examine the PLS predict at LV summary, latent variable or construct level. So now, again, you have to go to the software and then you have to click on this PLS predict LV summary. So now a small table is there that reflects this result. So now if the Q square predict value greater than 2% or less than or equals to 15%, it shows weak predictive power. If it is greater than 15% but less than 35%, it indicates moderate predictive power. And if it is equal to or greater than 35%, it indicates strong predictive power. So in our case, for happiness construct, it is 0.660. So it indicates strong positive predictive relevance. Values greater than 0 indicates predictive power. And if it is greater than 0.5 is considered as a high. And for the LS life satisfaction, the value is 0.136. It indicates small but positive predictive relevance, still above 0. So it has some predictive capability, though a weak compared to happiness. So in this way, you can find the model's predictive power at two different levels. The first one is manifest level, manifest variable level, or indicator level, or second is at a construct level. And you can find the results on the Pls-Sem at these 2 points. The first one is PLS predict MV summary, and second one is PLS predict LV summary. So after giving explanation of model explanatory power, you have to mention the results of predictive power of Pls-Sem. So thank you for watching this video, and kindly subscribe the channel for the next videos in this series.